In this video I covered the top 5 database system in 2025. This depends heavily on specific project requirements, such as data volume, complexity, scalability needs, and budget constraints. Careful consideration of these factors is crucial when selecting a database system. Before that, it is best to answer this question. What is database? A database is a structured collection of data that is stored and managed in a way that allows for easy retrieval, modification, and management. It organizes data in a manner that makes it accessible and usable for a variety of applications, typically through software that enables querying, updating, and data manipulation. In 2025, the database landscape will be shaped by increased demand for scalability, cloud integration, real-time processing, and advanced analytics. Here are 5 of the most important database systems, their key features, and examples of their application areas.
1. PostgreSQL. Type: Relational Database Management System, RDBMS. PostgreSQL is an open-source, highly extensible database known for its robustness, compliance with ACID properties, and support for advanced queries. It supports both SQL, structured data, and JSON, semi-structured data, making it ideal for complex, mixed workloads. Application area: web development, financial services, data warehousing, and geospatial applications. Example: Instagram uses PostgreSQL for managing user data, including media and interactions, offering scalability and complex querying capabilities. 2. MySQL. Type: Relational Database Management System, RDBMS. MySQL is one of the most popular open-source relational databases, known for its speed and ease of use. It is widely adopted for web applications, particularly in environments where a lightweight, high-performance database is necessary. Application area: content management systems, CMS, web applications, e-commerce platforms, and small to medium-sized applications. Example: WordPress, one of the most widely used website platforms, uses MySQL for managing website content, user data, and plugin settings. 3. MongoDB. Type: NoSQL, document-oriented. MongoDB is a leading NoSQL database known for its flexibility in handling unstructured or semi-structured data. It stores data in BSON, binary JSON, format, making it ideal for applications requiring fast, scalable, and schemaless data management. Application area: big data, real-time analytics, content management systems, IoT, mobile applications, and gaming. Example: Uber uses MongoDB to manage real-time ride data, trip information, and geospatial data for efficient matching of drivers and passengers. 4. CockroachDB. Type: Distributed SQL database. CockroachDB is a distributed SQL database designed for cloud-native applications. It provides horizontal scalability, high availability, and automatic replication across multiple nodes or data centers. This makes it highly suitable for mission-critical, globally distributed applications. Application area: high availability applications, global scale services, e-commerce platforms, and financial systems. Example: Aegean, a global payment company, uses CockroachDB to ensure real-time transaction processing across multiple countries and ensure fault tolerance. 5. Oracle Database. Type: Relational Database Management System, RDBMS. Oracle remains one of the most powerful and enterprise-grade database systems. It supports complex transactions, scalability, and strong security features. Oracle's database is designed for high-performance applications, offering both OLTP, online transaction processing, and OLAP, online analytical processing. Application area: large-scale enterprise applications, financial institutions, government agencies, healthcare, and telecommunications. Example: Wells Fargo uses Oracle database to manage large volumes of financial transactions, ensuring security, reliability, and high availability for its banking operations. At the end, it is best to answer this big question: why database? A database is essential because it efficiently stores, organizes, and manages large amounts of data, allowing easy retrieval, modification, and analysis. It ensures data integrity, security, scalability, and consistency across multiple users and systems. Databases enable rapid querying, complex transactions, and real-time access, which are crucial for applications in business, finance, healthcare, and more. They support data backup, recovery, and concurrency control, ensuring reliable and secure operations for modern software and services.